Hi everyone, we're on to the second half of this unit. All the first half we did operations of polynomials, adding, subtracting, multiplying. Technically the second part is still an operation because it's division, essentially division of polynomials, but we call it factoring, and we're going to start with this concept of common factoring. Now when you think about factoring, I think about a division operation. We'll show you why it's a division operation, but factoring, it is the process or the action of turning a number or a polynomial expression into a product of its factors. That's why it's called factoring. You're making something like a number or an expression represented as a product of all its factors. Okay, we'll show you how. Review. Write the number 20 as a product in as many ways as possible. So 1 times 20, 2 times 10, 4 times 5, 2 times 2 times 5 if we're doing prime factorization. Write the prime factorization of 20 and 28. Use factor trees. So 20. I'm going to divide by prime number 2. I get 10. Divide by another prime number 2. I get 5. And there it is. How about 28? Divide by 2, I get 14. Divide by 2, I get 7. 20. 2 times 2 times 5. 28. 2 times 2 times 7. What is the greatest common factor, GCF of 20 and 28? Well, remember when we did prime factorization, we look at pairs of factors, prime factors that are the same. 2 and 2, 2 and 2, 5 and 7 are not the same. So the greatest common factor is 2 times 2, and that equals 4. So the greatest common factor of 20 and 28, GCF, is 4. So far we've learned to write numbers as a product of their factors, but what about a polynomial? You can do the same thing. Remember, a polynomial is in factored form when it is written as a product of 2 or more factors. So here's a bunch of examples. In this course, we will look at factoring polynomials. When we factor, we write polynomial expressions as a product of its factors. The operation we are doing when we factor is division. By recognizing any common factors of polynomials with more than one term. So here's the ways. Of the form ax squared plus bx plus c where a equals 1. Of the form ax squared plus bx plus c where a does not equal 1. That are a difference of squares and that are perfect square trinomials. So this is all a look ahead on what we are doing with factoring. There's quite a bit to do in this unit. Today we'll focus on recognizing any common factors of polynomials. We call it common factoring, or I like to refer to as GCF factoring, with more than one term. Write the monomial 6x squared as a product in as many ways as possible. So like this, 6 times x times x, or 3 times 2 times x squared. Okay, or 3 times 2 times x times x. Okay, you get the idea. Write the binomial 6x squared plus 12 as a product in as many ways as possible. 6x squared plus 2. I'll show you how to do this in the next page or two, but think about if I distributed this back, that's 6x squared plus 12. I can also think of this as 3 times 2 times x squared plus 2. Okay, or I can do 3 times 2x squared plus 4. Or 2 times 3x squared plus 6. Which of the above answers will be the expression that is factored completely? Okay, it's this one, 6 times x squared plus 2. Explain. The terms inside the brackets, the terms inside the brackets cannot be factored further. So you know that it's completely factored or factored completely. With prime factorization of numbers, we stop when we have an individual factor as a prime number. With an algebraic expression, it is said to be factored completely if each individual factor with more than one term cannot be factored further. This term and this term, they share no more common factors. So I'll write that down. They share, or I can just say they do not have any more common factors. So it is factored completely. Next page. To factor a polynomial expression completely, first look for the GCF of all terms, greatest common factor. Let's do a polynomial, this time a monomial. Remember our example before was 20 and 28. Now let's throw some variables in there. What is the greatest common factor of 20a squared and 28ab? So when I think about 20a squared, I know 20 prime factorized is 2 times 2 times 5, and then I think of the times a and times a. And then when I think about 28ab, we prime factorize 28 on the other page. That is just 2 times 2 times 7. And then let's throw in that a and the b. Okay, just like we did greatest common factor, we line up the prime factorization, and we circle pairs of common prime factors. 2 and the 2, the 5 and the 7, nothing in common in both. A and the A, and then the A and the B, not in common. So the greatest common factor is 2 times 2 times A, or 4A. I should show you, well, you can prime factorize 20a squared. I should show it to you this way. So that is 10a squared. That is 2. That is 5a squared. That is a, and that's 5a, and then a. Hang on. Sorry. Let me do it over here. 20a squared. Oops. That's 5a squared divided by 5. That's a squared divided by a. That's a. So that's the 2, 2, 5a, and a that you see for the first one. The second one, let's do 28ab divided by 7. I get ab. Divided by a, I get b. And that's this second one here. That's how I get my prime factors. You can actually prime factorize variables. You just keep them as variables. All right, so the greatest common factor of 20a squared and 28ab is 4a. Use this information to write the completely factored form of this polynomial, 20a squared plus 28ab. Let's say we're adding them together. Show the division steps. So, if the greatest common factor is 4a, then I divide 20a squared divided by 4a. So I'm dividing out the factors. What's left? 20 divided by 4 is 5. A squared divided by a is a. Next one, the second term. So we did the first term. Let's do the second term. 28ab divided by the common factor of 4a. 28 divided by 4 is 7. A divided by a is 1, so I'm left with b. So what does this look like if I write it left to right? So I'm showing you the division steps. So if I factor out a 4a, inside the middle, or in the brackets, I'm left with a 5a plus 7b. So what I've done here is this term right here, this polynomial expression, I've divided by the greatest common factor, 4a, and I'm left with 5a plus 7b. If I multiplied it back, that's 20a squared plus 28ab, and that checks with the original expression. Okay, so hopefully you can see from this example that factoring is equal to division. Let's do the next one. What is the greatest common factor of 12x squared y, 18xy squared, and 24x cubed? Let's prime factorize each one. That's 12x squared y. Let's go 2. That's 6x squared y. Let's go 2. And that's 3x squared y. Let's divide by 3. That's x squared y. Let's divide by x. That's xy. Let's divide by x, and we're left with y. So there's the prime factorization of 12x squared y. What about 18xy squared? So let's keep going. Okay, and then I'm going to divide by x, divide by y. There's my prime factorization of 18xy squared. Let's go 24x cubed. Okay. Okay, so that's 24x cubed. Let's line it all up. For 12x squared y, oops. Oops. 12x squared y equals 2 times 2 times 3 times x times y. 18xy squared equals 2 times 3 times 3 times x times y times y. 24x cubed equals 2 times 2 times 2 times 3 times x times x times x. Okay, remember for greatest common factor, I'm going to circle all the prime factors that are the same for all three terms. So I have this 2. Let me use a different color. I have 2's. Okay, we're done with 2's because this middle term, 18xy squared, only contains 1, 2 as a prime factor. So we're done with all the 2's. So all the 2's are going to be eliminated. 3, I see 3's for all 3, so I'm going to do this. Okay. I can see that we've run out of 3, so I'm going to eliminate this other 3. Let's do x's. I can see that we've run out of x's in the middle term, so I'm going to eliminate all the x's. And then let's do the y's. Well, this last term, 24x cubed, does not have a y, so I'm going to eliminate all the y's. So what's my greatest common factor? 2 times 3 times x, and that equals 6x. That's a lot of work to find the greatest common factor. We'll show you a faster, more shortcut method that you need to learn to be more fluent with your factoring. But let's keep going here. Greatest common factor is 6x. What do I do with the 6x? So now I have this polynomial expression, 12x squared y minus 18xy squared plus 24x cubed. Each term will get divided by 6x. That is 2xy. Negative 18xy squared divided by 6x. That is negative 3y squared. And then 24x cubed divided by 6x, that is 4x squared. So these three terms are what's going to be left in the brackets when I factor out a 6x. I have 2x, let me just do this, 6x, I have 2xy minus 3y squared plus 4x squared. If I multiply it back, I get 12x squared y minus 18xy squared plus 24x cubed. And does that check? Sure does. Okay. That's a lot of work for common factoring. It needs to be more fluent and faster than that. The next page will show you that. First, this note on number 5. Jeff was asked to write the polynomial 3x squared minus 6x in completely factored form. He gave this as his answer. 3 times x squared minus 2x. Is Jeff's answer 3 times x squared minus 2x in factored form? Yes, it is. But is it completely factored? No, it is not. Explain Jeff's mistake and give the correct answer. Jeff forgot to factor out the x value. He should have factored out a 3x to begin, and that's x minus 2. Is 3ab times 4b squared minus 5ab minus 3b in factored form? Sure is, but is it completely factored? No. Explain and write in completely factored form. You must, we forgot to factor out the b, so must factor the b. So 3ab, let's factor out an additional b, and I'm left with 4b minus 5a minus 3, and that is 3ab squared times 4b minus 5a minus 3. Okay, next one is 2x minus 4 times x plus 3 in factor form. Well, yes it is, but is it completely factored? No. Explain in writing completely factored form. This term is not completely factored. I can factor out a 2, so that's x minus 2 times x plus 3. So must factor a 2 from the first term. Okay, let's do a series of practice factoring. Here's a tip. Find the GCF of the coefficients. So this is like coefficients are the numbers. Find the GCF of variables. What is the lowest exponent? That's the trick to the shortcut with factoring variables. Okay, greatest common factor. What is the greatest common factor of 12x squared and 15x? First, the numbers. What's the greatest common factor of 12 and 15? So you should develop some fluency and be able to give me the greatest common factor of any number by memory, or at least by practice, right? So 12 and 15, I'm thinking that's a 3, right? So I'm going to go 3. And then for the variables, I have an x squared and an x. It's the same variable, different exponent. The greatest common factor of variables that are the same but with different exponents is pick the one with the lowest exponent, and that's the exponent of 1, or just x. So your greatest common factor is 3x. That's the fast way to get greatest common factor. And then now I know we were doing this. We'll do it one more time, but I want to get away from doing this because you need to be more fluent. So 12x squared, so I'm taking this first term divided by the GCF, and then I take the second term divided by the GCF, and then I get my expression. You write it left to right as the greatest common factor on the outside, and what's left on the inside is the result of the division, or the quotient, 4x minus 5. That's why it's called factoring, is because now I've turned my polynomial expression into a product of its factors. Okay, so that's 3x times 4x minus 5. Let's do another one. But let's get away from this bulky division process, and let's make our factoring a bit more streamlined and a bit more fluent. 35m to the fourth minus 40m cubed. First, look at the numbers. What's the greatest common factor of 35 and 40? Well, that's going to be 5. I have m to the fourth and m to the third. What's the rule? Same variable, different exponent. Take the lowest exponent. That's your GCF for the exponent, 5m cubed. If I take a 5m cubed out from the first term, what do I get? So it's 35 divided by 5 is 7. M to the fourth divided by m to the third is m. Minus. Why is it minus? Because I have a negative 40 divided by 5. That's negative 8. And that's m to the third divided by m to the third. That's 1. So I'm just going to end it right there. Next one. 16a plus 24b minus 4c. What's the greatest common factor of 16, 24, and 4? Just 4. I have an A, B, and a C, all different variables, so I'm going to stop there. There's no variable that's part of the GCF. If I factor out of 4, first term, 16a divided by 4, that's 4a. Second term, 24b divided by 4, that is plus 6b. Negative 4c divided by 4, negative c. And we're done. Next one, 30p to the fourth minus 12p seventh minus 18p to the third. What's the greatest common factor of 30, 12, and 18? I got 6. I have p to the fourth, p to the seventh, p to the third. What's the lowest? All p's, so same variable. What's the lowest exponent? P to the third. I factor out a 6p cubed. First term, 30p to the fourth divided by 6p cubed. 30 divided by 6 is 5. P to the fourth divided by p to the third, just p. Minus 12p to the seventh. First the number. 12 divided by 6 is 2. Actually, I should do this. I have negative 12p to the seventh. What's negative 12 divided by 6? First the numbers. That's negative 2. And then p to the seventh divided by p to the third. That's p to the fourth. And then negative 18p cubed divided by 6p cubed. I'm factoring out a 6p cubed. What's negative 18 divided by 6? That's negative 3. P cubed divided by p cubed is 1, and we're done. Next one. 30a to the 10th b squared c minus 20a to the 4th b to the 6th. Okay, getting more complex. First the numbers, 30 and 20. What's the greatest common factor of 30 and 20? That's 10. I have a to the 10th and an a to the 4th, same variable. I take the lowest exponent. I have a b squared b to the 6th, same variable. I take the lowest exponent. And then I have a c, but the second term does not have a c, so there is no c for the GCF. 10a to the 4th b squared. First the numbers, 30 divided by 10 is 3. A to the 10th divided by a to the 4th, a to the 6th. B squared divided by b squared is 1, so I don't write any b's. And c divided by 1 is just c, so I have 3a to the 6th c. And then negative 20 divided by 10 is negative 2. And then I have a to the 4th divided by a to the 4th, that's 1, so I don't write it. And then I have b to the 6th divided by b squared, that's b to the 4th. And done. All right, negative x to the 5th minus x cubed. Anytime I have a negative sign in the beginning, I'm going to say negative 1 is part of my greatest common factor. A general convention we like to use is that any of the lead terms, we want it to be positive. Okay? Now, I have an x and an x. What's the greatest common factor of x to the fifth and x to the third? Lowest exponent. So I factor out a negative 1x cubed. First term, this one. Let's write it out. This one's a tricky one. That's like a negative 1 out in front. That's going to be a positive 1. And x to the fifth divided by x to the third, that's x squared. And then the next one, negative 1x cubed divided by negative 1x cubed. That's going to be x cubed divided by x cubed, negative 1 divided by negative 1. That is just plus 1. And that's it. Okay. Hopefully you get an appreciation for all the steps that are involved, and then just developing some fluency and some shortcuts in your GCF factoring. Okay. Next one, the algebraic expression 3 times x minus 4 plus 6 is neither in factored form or simplified form. Write 3 times x minus 4 plus 6 in simplified form. What does that look like? That's 3x minus 12 plus 6, and that equals 3x minus 6. In factored form, 3x minus 6, I'm going to factor out a 3, and that's x minus 2. Complete the following table. Let's go back and forth. Completely factored form, I'm going to multiply through. That's 4x squared minus 5x. If I have 7m to the 6 minus 4m cubed, greatest common factor of 7 and 4, there's no whole number that fits that, except 1, so I'm not going to factor out a 1. But m to the 6 and m to the third, that's m to the third, greatest common factor, and I'm left with 7m to the third minus 4. Next one, I'm expanding, or I'm putting in simplified form. That's 15a minus 20b plus 5c. Next one, 7a squared minus 8ab plus 5ac. 7, 8, and 5, there's no greatest common factor other than 1. I'm going to leave that alone. A squared, ab, and ac. The a's, it's just a because the lowest exponent is 1. And then the b and the c do not have greatest common factors for all three terms, so it's just a. So factor out an a, I get 7a minus 8b plus 5c. 4ab squared, let's expand that. That's 20a cubed. 20a cubed b squared plus 4a squared b cubed plus 16ab cubed. Last one here, 40x to the fourth y cubed minus 24x to the fifth y squared plus 56x cubed y cubed. First the numbers, 40, 24, and 56. I got 8 as my greatest common factor of the numbers. And then the x's, x cubed is the lowest, and then the y's, y squared is the lowest. So let's do this. 40 divided by 8 is 5. X to the fourth divided by x to the third, x. Y cubed divided by y squared is y minus, or let's see, 24. Negative 24 divided by 8 is negative 3. X to the fifth divided by x to the third is x squared. Y squared divided by y squared is 1. And then 56 divided by 8 is 7. X cubed divided by x cubed is 1. Y cubed divided by y squared is y. Okay, and that's it. All right. Ooh. One more page. So far, we've only explored a common factor that is a monomial. What about a common factor? What about common factors that are binomials? Factor 5xa minus 3a. Well, I'm going to factor out an a. That's 5x minus 3. Use similarities from part A to help you factor 5x times y minus 2 minus 3 times y minus 2. Imagine this is your a value here. I can factor out a y minus 2, and I'm left with 5x minus 3. Simplify 5x times y minus 2 minus 3 times y minus 2. So I'm going to multiply it out. 5xy minus 10x minus 3y plus 6. Simplify the factored form from part B. So I have y minus 2 times 5x minus 3. So I factor out the binomials. I'm up to 5x minus 3. Let's FOIL this and see that it's the same as this value. So that's 5xy first, outside, minus 3y, then inside, minus 10x, then last, plus 6. Let me rewrite it. 5xy minus 10x minus 3y plus 6. And voila, they are the same. Are the answers from part C and D the same? Yes, they are. Factor completely. So a little bit of practice here, and then we are done, folks. 2n minus 5, 2n minus 5. If it helps, just imagine a and an a there. 2n minus 5. I'm left with 4m plus 7. 4m plus 7. Factor out x plus 3. I'm left with 2x minus 7. 2x minus 7. X minus b, x minus b, x minus b. Or sorry, a minus b. I'm left with x plus y plus z. X minus 5, x minus 5. I'm left with 2x minus 4. 2x minus 4. But we need to factor completely. X minus 5, I can factor out a 2. And I have x minus 2. And then let's just rewrite it with the 2 out in front. Just convention. And that is it. Okay? Last couple notes here. Recall. Find the GCF of the coefficients. That means the numbers. And then find the GCF of the variables. What is the lowest exponent of common variables? Okay? And then here's what we did today. Factoring a polynomial where there is a common factor. Find the GCF. The largest expression that divides into all terms, and write it down. Divide each term by the GCF and write the answer in brackets as a product of the GCF. Check your answer by multiplying. So you multiply back distributive property. If the original expression is not in simplified form, the way to check is to multiply both the original expression and your answer to see if both are the same. Okay, folks, next page. I got lots of practice. Get going on it, and we'll see you for the next lesson.